In this lesson, we're going to look at 3 different functions, and we're going to do our work on a foldable so that we can see similarities and differences. So the first thing we need to do is we need to fold our foldable. So take the outer edge of each side and fold it to the center. So we have what will be called a trifold. So we have a trifold like this. And then what we're going to do is we're just going to cut, open it up, and just cut to the first crease on each of these lines. Cut to each crease, not beyond it. You can see that we're going to be covering a lot of information in this lesson. It's supposed to be basically an introduction of a lot of concepts that you need to know in Algebra 2. Okay, some of it's review and some of it's not. So let's look on the front side. And let's just talk about some of these things that we already know. So when I'm talking about a linear function, let's just sketch some ways a linear function could look. So linear means line. So I could have a line that goes in a positive slope. So here I'm going to say that this slope is positive, or I could have something that has no slope at all. So here I would say the slope is 0 because there's no slope. Or I could have a line that goes like that, and that would be a negative slope. So here my slope is negative. So 3 possibilities there for slope. So if you recall, some of our functions have different forms. So standard form for a line is ax plus by equals c. Point slope form is y minus y1 is equal to m times x minus x1. And then we have slope-intercept form, which is y equals mx plus b. We also have this thing called the parent function. So you know lines can be just about anywhere on our graph, but we have something called a parent function, and our parent function is really just very basic. The bare minimum you need to have that function. So the parent function for a line would be y equals x. So that's very important that you remember what the parent functions are. So let's look at a quadratic. So for a quadratic function, we have something that is a parabola. It's like a bowl. It could be facing up, or it could be facing down. Okay, it can face either way. So this is a parabola. So let's write that. That's a word that you would need to know. So this is a parabola. It's like a satellite dish. So now we talk about standard form. we would have y equals ax squared plus bx plus c. So notice this is written a little bit differently than our standard form is for a line. We start usually with y equals. The quadratic has a square. Vertex form would be y equals a times x minus h squared plus k. And we'll be talking more about that form later on. And then our parent function is the bare minimum of what we need, which would be y equals x squared. That's the bare minimum you need to draw a quadratic. The last function we're going to look at on this foldable is our cubic function. And our cubic function takes on a certain shape. It could look, I'm going to kind of exaggerate some of these curves a little bit, because sometimes it might be exaggerated like that. Or it could be in this direction. Okay, so that's cubic. We don't have any particular name that we call that particular shape. So let's talk about standard form. So standard form, again, we're going to start with y equals, this time it's ax cubed plus bx squared plus cx plus d. Vertex form would be y equals a x minus h cubed plus k, and the parent function is the bare minimum you need to have a cubic function, which would be y is equal to x cubed. So when we look at, especially between the quadratic function and the cubic functions, we can see some similarities. Notice how my exponents are going down. That's a 2, there's a 1, there's a 0. This is a 3, there's a 2, there's a 1, there's a 0. Okay. Notice vertex form. We'll be dealing a lot with vertex form in another unit. But notice how I have a parentheses and x minus h in the center. The only difference between my quadratic and my cubic is my quadratic has a square here and my cubic has a 3 for being cubed, and then plus k plus k. So you're going to find that there's patterns, so you need to start looking for the patterns. So in the next video I'm going to look at the left inside of this foldable.